So hello, and this is a test video of our first lesson in Algebra 2. I record these videos, post them to YouTube, and link them on our class website. So if you are ever absent, or if you don't understand something quite as well as you think you did when you were in class, watch the video. And my lessons are pretty standard, the way we go through them. Try to touch all the bases that I'm required to and that I think you need in order to learn the material. So this will be a pretty good example of what to expect as we go through this class. So first, we in Hampton City Schools think that you need a little bit of a review of algebra skills before we press on with the new Algebra 2 skills. And today we're going to cover properties of real numbers and algebraic expressions, which are sections 1.2 and 1.3 in your book. As you can see by the SOLs covered, they are actually both Algebra 1 skills. For Green Day classes, I would expect that we would have a quiz on the 13th of September and a test on the 19th. For White Day classes, I would expect that we will quiz on the 14th and test on the 20th. Okay, we are expecting to review today the properties of real numbers very briefly. In fact, most will be on a handout that I'll give you. And then we're going to deal with algebraic expressions, using order of operations, combining like terms, things that you've done before, but you might need to be refreshed about. Okay, sets of numbers. In fact, in this class, we are responsible for more numbers than just real numbers, but we're going to start with real numbers, what we call real numbers. We always start on the inner circle of this. The most limited set of numbers we have are called natural numbers. They are the counting numbers. So you start 1, 2, 3, and this dot, dot, dot that you see here, that means it goes on forever. Right? If you add a 0 to that list, then you get the whole numbers. Okay? If you go to positive and negative whole numbers, that's called integers. Now, any number that can be represented as a fraction, even if it's not represented as a fraction, is considered a rational number. So you can see in this list that there's clearly, let me get my pen how I want it. There are clearly some rational numbers because that's a fraction, and that's a fraction, 2/3, 5/4, right? But, why is it that 1 and 2 are fractions? Because you could write them like 1/1 and 2/1. And decimals that either repeat themselves or terminate could be written as fraction. I mean, 0.222, that's 3 decimal places to the right, so that would be 2,222 over 1,000. So it could be written that way if we wanted to. I will leave out how is it that you would take something like 0.3? Repeating. Why is it that could be written as a fraction? Well, we know that it can be. 1/3 is the same thing as 0.3 repeating. And there is a process. You could turn any repeating decimal into a fraction fairly easily. Now, irrational numbers are numbers that are not rational. That ir right there stands for not. So these are mutually exclusive. There's not going to be any numbers that fall on both the left side of this line and the right side of that line. So irrational numbers, if they were written as a decimal, would not terminate and they would not repeat. And the most common number that we think of for this is pi, right? Pi, 3.14159 ... I don't even know if I got that much right, but it goes on forever, never repeats itself. Another common way to suggest that this number is irrational is to use a square root that can't be simplified. right? The square root of 2 can't be simplified without turning it into a decimal. And if you did, it would not terminate and would not repeat. So those are the common ways to look at irrational numbers. So if you add up all the irrational numbers to all the rational numbers, you get what's called the real numbers. Now, are there any numbers that are not considered to be real numbers? And the answer is yes. Right? Real numbers are actually a subset of what we call complex numbers. And there are some numbers, some complex numbers, that are not considered to be real numbers. And we actually deal with those in this class. And they will blow your mind when we get to them, but they are called imaginary. So imaginary numbers are not real numbers, and the real numbers plus the imaginary numbers make up the complex numbers. So there is a bigger set of numbers than real numbers, but most of what we just did, that falls under the real numbers. So properties of real numbers. You've done these many times before, and you may not always know the names of these properties, but you know how to use them, which is obviously more important than actually knowing what the name is. But knowing the names of these properties is tested. It was tested on the Algebra 1 SOL. It's tested on the Algebra 2 SOL with maybe one question, maybe two, not many. We're not going to spend a lot of time going over this, commutative, associative, distributive. I'm going to give you a handout right now. And this is the comprehensive list of properties that you would be expected to know in this class. And I will refer to the properties during the class. If we use a property, I'll probably say, what property is it that says that I can do that? But we're not going to spend too much time on that right now. So let me pause the video for a second while I hand out the... Okay, let's go ahead. Then we get to the next section, which is called algebraic expressions. Well, sometimes you'll say variable expressions, right? A variable is an unknown quantity, usually represented by a letter. Usually that letter is x, but not always. And the best way to explain what an expression is to explain what it is relative to what is an equation and what is a function. So an expression is something like 2x plus 1. You see the variable x there, right? An equation is 0 equals 2x plus 1. Right? What is it that makes that an equation? Obviously, it's the equal sign. Right? A function is y equals 2x plus 1. Okay? What is it that makes that a function and not just an equation? Well, it's got two variables. Right? Two variables make that a function. Okay, so what do we do with each one of these? Well, what do you usually do with an equation? What are usually the directions when you get an equation? The answer is you solve. 0 equals 2x plus 1. You would solve by isolating the x. You would find out the value of x that makes that statement true. For a function, you really can't do that because you have two variables, right? If I plug in a value for x, I can calculate a y. If I plug in a different value of x, I can calculate another y. And I could keep plugging in values of x and get infinitely many values of y.
Mr. Kaysen, to the main office, please. Mr. Kaysen, please report to the main office.
What is the result of all that? A whole bunch of points, which we graph. So equations you solve, functions you graph. Right? Expressions don't have an equal sign. There's two things we usually do with those, and that's what we're going to be looking at today. We are going to evaluate, and we are going to simplify. To evaluate an expression means to substitute given values for variables, assuming there's more than one, and then simplify using order of operations. So as we look at this worked out example, 7 times a plus 4 in parentheses plus 3b minus 8. Evaluate for a equals negative 4 and b equals 5. Right, that means that in place of the a, we put negative 4. In place of the b, we put 5. Okay, at that point, this is an order of operations process. All right, you all remember PEMDAS. Right, we should do parentheses and then exponents and then multiplication and division from left to right and then addition and subtraction from left to right. So in this case, let's see, we've got parentheses to deal with. So we add, what's negative 4 plus 4? 0, right? And next step, there are parentheses here, but there's no operations going on inside of them. So they're really just, you might as well have like a multiplication symbol in between the 7 and the 0 and the 3 and the 5. So the next thing to do is multiply. 7 times 0 is 0, 3 times 5 is 15, and we have our negative 8. And then we add and subtract from left to right. So 0 plus 15 is 15, minus 8 is 7. Right? That's what we mean by evaluate an expression. All right, let me do another one here, one that's not worked out. Okay, so x over 2 plus y squared for x equals 1 and y equals 1/2. So in place of the x, I put a 1. In place of the y, I put a 1/2. Right, following PEMDAS, the P for parentheses. Again, there's nothing going on inside the parentheses, so really we're going to move to the E for exponents. All right, what is 1/2 squared? All right, that would be 1/2 plus 1/4. Okay, now we've got to add fractions. Since we don't have the same denominator, we need to make a common denominator. Right, what would be the least common denominator between 2 and 4? And you would say 4. So in order to make these have the same denominator, I'm going to multiply the first term by 2 over 2. All right, that's going to give me 2 over 4 plus 1 over 4, which is 3 over 4, 3/4. Okay, why don't you try? These are what I call U-tries, right? U-try. This is part of your classwork credit. Is you need to go follow along with these, try them. Usually when you do this, I'll pause the video and we'll go around the class and make sure that everybody's getting the concept that we're working on right here. And something I'm going to try this year that I have not done much of in the past is that after I've checked a student or two, they can also help to check fellow students, especially in the bigger classes. That might actually help us to keep a good pace going so we don't bore everybody. So if you're getting this by video, then pause the video, do the problem, and when you're done, then hit play, and you'll see me working this out. So, okay, now would be the time to pause. So I'm going to start this problem. I need to put in x equals 6 and y is negative 3. Okay, so 2 times 36 minus, what is negative 3 squared? Positive 9. Okay, parentheses, 36 minus 9, 2 times 27 divided by 3. Okay, now we've got a few different operations to do here. Doesn't matter which, it's all multiplying and dividing. So we're supposed to do those from left to right, but we actually only have one term. So what do you think would be easiest to do? in my mind, it's probably easiest to divide 27 by 3. I mean, you can put this in your calculator, that's fine. But without a calculator, I would probably turn this into a 2 times, like this, 27 over 3, which is 2 times 9, which is 18. You could have multiplied 2 times 27, that would be 54. 54 divided by 3 is 18. Either way. Okay, here's a little word problem kind of thing. Okay, in football, a touchdown, TD, is worth 6 points. An extra point kick is worth 1 point, and a field goal is worth 3 points. What algebraic expression models the total number of points a team scores in a game, assuming each scoring play is one of the 3 given types? Suppose a football team scores 3 touchdowns, 2 extra points, kicks, and 4 field goals. How many points did the team score? Now, especially if you're a football fan or a sports fan of some kind, you probably don't need an algebraic equation to figure this one out. But the whole point of it for us is let's set this up like it's an algebra problem. Right, so before I do that, I am going to define my variables. They've given us these abbreviations for touchdown and extra point kicks and field goals, but I don't particularly want to use those as my abbreviations for the variables. So how about if I just say x equals TD, y equals extra point kicks, and z equals field goals. Now, if P is points, then we would be saying that points equals, right? How many points for a touchdown? 6. So 6x. Plus 1 point for each extra point kick, so that would be plus 1y. Plus 3 points for each field goal would be 3c. So that would be our equation that describes the number of points, if that's how you got all your points. Now, there is one other way you get points in a football game, and a football player might know that. I bet you a general sports fan might not. So if anybody wants to throw that in there, that you can say it now. Okay, I'm going to figure out now. If you scored 3 touchdowns, 2 extra point kicks, and 4 field goals, that'll be 6 times 3 plus 2 plus 3 times 4. So that's 18 plus 2 plus 12, which is 32 points. Okay, here's some vocabulary. Terms. In an algebraic expression, terms are separated by plus or minuses for addition and subtraction. Right? That's not the same thing as, for example, if I had 7w times negative 6. That's not 2 terms. That negative there is not a minus sign for subtraction. That's telling you that it's a negative number. So that should not be confused with 2 terms. So terms are separated by pluses and minuses. In this case then, since there's a plus and a minus, that means we've got 3 terms. Okay, if the term has variables and there is a number in front of those variables, those are called coefficients. Right? That's a math term that we will use, and you're expected to know. The negative 6, that term doesn't have a variable with it, so it's just called a constant term. Right? Constant meaning it doesn't vary. There's no variable, and variables are the things that vary. So it is a constant term, or you can just even say it's a constant. Minus 6, that's a constant. Okay, like terms have the same variables raised to the same powers. So which are the like terms in this expression? And let's see, same variables raised to the same powers. So these are like terms because they have both of x squareds. These are like terms because they have y to the third z. So the same variables, and those variables are raised to the same powers. Now, you combine like terms by adding or subtracting the coefficients, right? But you do not change the variables or the exponents, right? So like if I want to add 3x squared plus 5x squared, what I'm really doing here is going 3 plus 5, those are the coefficients, times x squared, which is 8x squared. You know, now we don't often show this step of writing in parentheses the 3 plus 5, but that is what we're doing, right? And let's see, 9y to the third z's minus 4y to the third z's. How many y to the third z's do we have if it's 9 minus 4 of them? And that would be 5. Okay, and lastly, we have this one term that's just sitting there by itself. It doesn't have any other like terms to combine with it, so it stands alone. Okay, normally you write expressions with the term on the left, which has the most powers of the variable, and then it goes in decreasing order. This one we'll leave like it is. Remember that when you have like terms in an expression, you should always simplify them by combining like terms. Right? This becomes important when we get to the next section where we are solving equations. Okay, let me show another example here. Combine like terms. Okay, what is the first operation I should do here? The answer is distributive. Okay, now where is distributive property going to come into play? Right. My bet, since I'm doing this by myself, there's no students out here to answer back to me, is that everybody's going to see this, 2 times k, 2 times 4m. But actually, you also have this negative in front of parentheses. That needs to be distributed too. Right? This negative is making everything that's inside parentheses the opposite sign of what it was in the parentheses. So you could think of it like a -1 times. So this is going to be negative 3k minus m plus 2k minus 8m. Okay, Next, we need to combine like terms, right? Which are the like terms in that expression? And the answer is 3k plus 2k, negative m minus 8m. Okay, what is negative 3k plus 2k? Right, that would be negative 3 plus 2 times k. And then we're going to have plus negative 1 minus 8 times m. Right, that's these two. The coefficients are negative 1. You don't see the 1, but it's there, and negative 8. So this is negative 3 plus 2 is negative 1. So I can write that like negative k minus 9m. So now here's your second you try in this class. Combine like terms in this expression. And again, if you're watching this video at home, now would be the time to pause, and when you're done, hit play. Okay, like the last problem, I need to distribute first. Why is that not going? Oh, I'm hitting the wrong spot. So I need to distribute. So that's negative 8a minus 3b plus 20a minus 50b. that little stray dot. Okay, now I've got the like terms are negative 8a plus 20a, negative 3b minus 50b. Combine like terms by combining, adding, or subtracting the coefficients. Negative 8 plus 20 is going to give us 12a. Negative 3 minus 50 minus 53b. Right? Again, note that you do not change the exponent on the a or the b. You don't make that 12a squared or 53b squared. Right? If it started out as an a and an a, then it ends up as an a. Right? It's a b, so this is a b. Don't make it into a b squared. That's not how adding and subtracting algebraic terms works. Okay, so that, again, mostly algebra review. This is the same slide that we looked at the beginning. And you can see that we applied properties of real numbers to simplify expressions. We evaluated expressions using order of operations. You could say, I'd copy this directly out of the Algebra 1 SOLs, and we didn't get a chance to use absolute values, square roots, and cubed roots yet, but we will. So that is the lesson for today. The homework is here in your textbook, and you should have time to work on this in class, I hope. Eventually, when you have your Chromebook, even if you don't have your Chromebook, you should, if you can log, I'm not sure how it works, but again, I'm kind of new to this Google Classroom stuff, but there should be a link to the online textbook, so you don't have to carry your textbook around. I know in the first few days, we're going to need our textbooks for a while, but eventually, hopefully, you won't need that. Okay, remember that the way homework works is this is due at the beginning of next class, right? I won't pick it up, but I will come around and check it, make sure I'm judging it for effort and completion. I might ask you a few questions about what I'm looking at. And if you get all the credit, it'll be 2 points. If you don't have it, you can still do it for partial credit up until the test. Or if you don't actually do the whole thing, you get a partial credit, which would be 1 out of 2 points. So with that, this was a test video, and I'm going to try to post it to the class website.